All right, finally we're in chapter 3, section 3.6, so that means we're coming to the end of the chapter, and you guys should be in a place where you're feeling like you're ready to take a test because the test is coming up. Remember to let me know that at the end of chapter 3, at the end of section 3.6, you need to take the 3.6 quiz, as you should have already taken the 3.5 quiz. We'll talk about that later. All right, so this section is called, we're looking at proportional and non-proportional relationships, and basically, here's our vocabulary for today. Proportional relationships, when the relationship between two variables, say x and y, can be defined as y equals kx, this guy over here, looking familiar, where k does not equal 0. When we have a situation like that, you guys recognize this as direct variation, right? This looks a little bit like direct variation. You remember that from a couple of sections ago? And really it is. So proportional relationship is another look at direct variation. Notice that that direct variations are proportional. The graphs of proportional relationships always pass through the origin. Let's take a look at the first example, proportional relationships. Here we have a soccer team that's donating money to a local charity for each goal that they score. So if we look at this chart here, we can see that we have a relationship that makes logical sense. It looks like for each X number of goals, they donate $75, if you can see that. So as we observe that, we're going to try to answer the following questions. The first one says, graph the data to determine the relationship. So when we graph the data, and I'm feeling some type of way because I feel like I'm not going to do a really good job of graphing, but I'm going to try. Ooh, that's a terrible y-axis, but I don't really have the ability to delete, so we are going to deal. So here's my x and y-axis. My x-axis is going to correspond to the number of goals, so I'm going to put an x here, and I'm going to just mark off spaces that are as equivalent as I possibly can to represent the number of goals. And so that's 1, 2, 3, 4, 5, 6, and so on. And then along the y-axis, I know this is crooked and some of you are in pain right now. I apologize. I'm going to try to think of it in a straight way. So notice that I'm counting up to a pretty high number, 375. So I think it might make sense for me to count by 50s. So in doing so, I'm going to put 100 here, and I'm going to put 200 here. So each hatch mark refers to 50. And 300 will go here, and this one right here will be 400. So I think that's enough to accommodate the data that I have. So now if I'm graphing this, I'm going to, for the first goal, I get 75. 75 will be right about here. Second goal, I get 150, which is going to be right between 100 and 200. For three goals, we get 225. Not quite 250, between there, right? We get that. 4 goals, we get 300, so we're right here. 5 goals, 375. And that is pretty, let's see, this looks terrible, people. Something like that. Something like that. Something close to, yeah, I don't know. All right, so what you notice here is that we do have a graph that does this. Now, I did connect the line here just so we could see that it goes to the origin, though it doesn't really make sense to connect the line because we can't really have half goals. We can't really account for all of the points in between these. So truthfully, this should be a discrete graph. So we've done the graphing piece, and it would have been really satisfactory for me to just leave it as dots. Then it says write an equation to describe the relationship. That equation would be y, since this is a proportional situation, then we know that it's also direct variation. Y equals k times x is what we're dealing with. Clearly, y is equal to 75 times x. And we kind of established that before when we were looking at it. We realized for every goal we get 75 bucks. All right. The next one is use that equation to predict how much money will be donated for 12 goals. So in this case, if we're dealing with 12 goals, we know that x would refer to the goals. So y is equal to 75 times 12. I'm going to multiply that, and I'll get my answer. Let me see real quick. So I don't know how I got back here, but let me see if I can get back to where I want to be. Okay, here's where we want to be. So we had the graph that disappeared. I apologize. We also had the equation that we were comfortable with, which came out to y is equal to 75 x, and then afterwards we were determining y is equal to 75 times 12, and I believe this might be a great place to check me. The answer is 900. So they would raise $900 if indeed they were able to score 12 goals. Let's look at another example. Okay, so I'm actually going to not do another example, and I'm going to skip this, and I'm going to end it here. The other example was really just to have a graph and create an equation. I think you guys can actually do that. I think one example is enough for you to proceed and finish off section 3.6. Please let me know how you guys are doing. We'll talk tomorrow. Have an excellent day.